In this example, we're going to continue, in this video, we're going to continue our examples of hypothesis testing for two means or two proportions. In this video, we're testing claims about two means where the population standard deviations are not known. So our first example says the number of grams of carbohydrates contained in 1 ounce servings of randomly selected chocolate and non-chocolate candy is listed here. Is there sufficient evidence to conclude that the difference in the means is statistically significant? Use alpha equals 0.10. So I can see that I'm being asked to check if there is sufficient evidence to conclude. So that gives me an idea that I'm performing a hypothesis test. I see the keyword difference, so I know my alternative statement's going to be a not equal to. I know that I'm talking about number of grams in candy, 1 ounce servings of candy. And I'm testing claims about the mean number of grams of carbohydrates in 1 ounce servings of candy. And I'm given raw data. So I'm going to start by defining those means. So this is mean number of grams of carbs in chocolate candy. And then mean 2 is the mean number of grams of carbs in non-chocolate candy. I'm given an alpha of 0.10. I'm going to write my hypotheses. H null, H A. I'm comparing the two means. Null is always equal. Alternative, we're testing a claim about a difference, so not equal. And this is a 2-sample t-test for two means. And I know that it's a t-test because nowhere in the wording of this question was I given a population standard deviation. Instead, I was strictly given sample data, meaning I'm going to have to figure out the sample means and sample standard deviations on my own, or more likely, since it's 2025, I'm going to have my calculator do it. So I'm going to go ahead and put chocolate in list 1 and non-chocolate in list 2 on my calculator, and then I am going to call 2-sample t-test. And let's take a look at what that asks us for. So stat tests 2-sample t-test is option 4. And in this case, we have data. So I need to put my data in lists because that's the first thing it's asking for is where is my data. So stat, and then we're going to go ahead and enter that data here. So I can see that my data is now in my calculator. I'm going to go ahead and go back to stat tests, 2-sample t-test, and it's asking me for list 1 and list 2. It's asking where I put those two lists of data, and we did put them in L1 and L2. It's asking me about the frequencies for both of those lists. And since neither of our data was grouped, those should stay 1. It's going to ask us about our alternative, and we're looking at a not equal to scenario. And then it's going to ask pooled. And for this class, we are going to strictly stick to no. We are looking at situations where we are not pooling the data. That goes beyond the scope of intro stats. So in this case, everything is already set up based on what we want. We're going to go down to draw, and the calculator draws our picture for us and gives us those values. So I have my t-curve. I can see that I have a t-test statistic of negative 1.220 and a p-value that's rather large at 0.2406. So almost 25% of the curve. Marking where that falls, negative 1.2 is sitting a little past negative 1. Its positive buddy would be over here at just past positive 1. And these tails represent that quarter of the data. Because my p-value is so large, my p-value is much greater than my alpha, more than double, I'm going to fail to reject the null. The sample data, specifically the difference in the sample data, is within those two standard deviations of what I consider common in the population. So I'm not far enough from that middle value where they are equal to be concerned about there actually being a difference here. So we do not have sufficient evidence to conclude that there is a difference in the means or that the difference is statistically significant. Let's go ahead and try one more. The next one says the mean noise level of 20 randomly selected areas designated as casualty doors was 63.1 decibels, and the sample standard deviation is 4.1 decibels. The mean noise level for 24 randomly selected areas designated as operating theaters was 56.3 decibels, and the standard deviation of the sample was 7.5 decibels. At alpha equals 0.05, can it be concluded that there is a difference in the means? So I'm going to go ahead and define the means that I'm asked about in the question. So I'm looking at mean noise level in both cases. And the only difference is where in the hospital I'm measuring these levels. So the first area that they mentioned was casualty doors. So mean noise level in, come on pen, not casualty, casualty. And then the second area mentioned was operating theaters. So mean noise level in operating theaters. I'm given a whole bunch of information. The very last sentence, I'm given the level of significance as 0.05. For casualty doors, I'm told that there was a random selection of 20 areas and that the mean for that area was 63.1 and that the standard deviation for the sample was 4.1. For the operating theaters, I'm told that I sampled 24 random areas and that the sample mean noise level was 56.3 with a sample standard deviation of 7.5. And I don't know why I stopped subscripting here. 2, 2, 1, 1. Next, I'm going to state my hypotheses, so null and alternative. I'm testing claims about means, so mean 1, mean 2, mean 1, mean 2. I know my null is always equal. My alternative, I'm testing a claim about a difference, so not equal. And we're going to go ahead and go straight to our calculator. So stat tests, and this is a 2-sample t-test because I have sample standard deviation and not population values. In this case, I have statistics, so it's going to ask me for something slightly different. So this function's asking for x bar 1, s1, and n1. And then the same for sample 2, x bar 2, sx2, n2. And then similar questions, I need to know my alternative, and I need to know if it's pooled. And we're always going to leave pooled set to no. So we'll go ahead and copy this over 63. Try that again. 63.1, 4.1, 20, 56.3, 7.5, 24, and we're testing a difference or a not equal to. We're given a test statistic of 3.811 rounded and a p-value of 5e to the negative 4, which I know I can round to 0. If I wanted to be exact, that's 5 times 10 to the negative 4, which is equal to 0.0005. which is much less than 1%, so rounding to 0 in this case is fine. I'm going to quickly sketch my picture. And at 3.8, I'm almost out at 4, so I'm way out here in my tails. Which explains why that p-value, or the area in the tails, is coming out as approximately 0. Since my p-value is so very small, significantly smaller than my alpha, I'm going to reject my null hypothesis. And since I am rejecting the statement that they are equal, I am providing evidence that there is a difference in the mean noise levels between casualty doors and operating theaters. All right, if you have any questions in the video, feel free to send me an email or drop by office hours. Otherwise, I will see you in our last video for week 5.